Good morning, dear children. So, last class we did alkenes, hydrocarbons. Hydrocarbons are of three types. If you go specific, they are alkanes, alkenes, and alkynes. Alkanes will have a single bond, carbon-carbon single bond. Alkenes will have carbon-carbon double bond, and alkynes will have carbon-carbon triple bond. So, what are alkynes? Alkynes are a homologous series of unsaturated hydrocarbons. They are unsaturated hydrocarbons because the valency of carbon is not completely filled with hydrogen because of the triple bond present between carbon and carbon. Hence it is unsaturated. That means more hydrogen atoms can be added to alkynes. That's why they are unsaturated hydrocarbons. They are called unsaturated hydrocarbons because each molecule can still add on 4 atoms of hydrogen. So why they are called unsaturated hydrocarbons? Because each molecule can still add on 4 atoms of hydrogen. The general formula of alkyne series is CnH2n-2. So if you follow this general formula, you will get series of compounds under the family alkynes. If C is 1, then the compound formed the compound will not form. At least 2 carbon atoms are needed because alkynes are the compound with at least triple bond between carbon atoms. So if there is one carbon atom only, the compound does not exist. So methane does not exist. So the first member of the homologous series alkyne is ethane, because ethane will have 2 carbon atoms where we can show triple bond. So the triple bond involves sharing of 3 pairs of electrons in covalency between carbon atoms. The alkynes are also called acetylene series. So these alkynes, the common name for alkynes are acetylene. The common name for alkyne is acetylene. So alkynes, the homologous series alkynes are also called acetylene series. Alkynes are named like alkenes, but the suffix yne is used instead of ene. So while naming alkanes, the suffix we use is ane. For alkenes we use ene, and for alkynes we use yne. So what are alkynes then? Alkynes are a homologous series of unsaturated hydrocarbons that contain carbon-carbon triple bond. Carbon-carbon triple bond. You can see the example here. Alkyne series of the first 3 members with molecular and structural formula. Common name acetylene, IUPAC name ethane. Since there is eth, word root is eth, means there will be 2 carbon atom. C2H2. You can see here C triple bond. Okay, there is triple bond between carbon and carbon, so that's why they fall under alkyne. And since 3 of the valence electron are engaged in making triple bond, so 1 valence electron, it is sharing with hydrogen. Okay, each carbon atom is sharing you can see here this is triple bond, this is triple bond, 1 2 3, so triple bond. And this carbon will have 4 arms, so 1 2 3, and 1 arm is only left. So 3 of the valence electron of this carbon is shared with 3 electrons of this carbon atom. As a result, here are 6 electrons, or 3 pair of shared pair of electrons are there. So 3 plus 3 and 3, 6 plus 2, 8. For this also 6 plus 2, 8. So this hydrogen, that means they can have 1 hydrogen each. Now how many more hydrogen can be added? For this you can go back to alkane. If had it been alkane, okay, had it been alkane, alkane would have 6 hydrogen atoms. That means 4 more hydrogen atoms can be added to these. 4 more hydrogen atom can be added to this molecule. As a result, it is unsaturated hydrocarbon. So this is the triple bond, and the name of this compound is ethine. IUPAC name for this compound is ethine, and common name for this compound is acetylene. This is the structural formula and this is molecular formula. If you go with C1, 2, 3, and there is at least one triple bond. There is at least one triple bond. It doesn't mean that there has to be triple bond between each and every carbon atom. No, it is not possible. At least 2 carbon atom. Okay, at least there should be a triple bond between 2 carbon atoms, that much only. So triple bond between these 2 carbon atoms, and this is always you have to count 4 arms for each carbon atom always. So 1, 2, 3, and here 4, and here 1, 2, 3, 4. For this 1, 2, 3, and this is 4. So how many hydrogen atoms are here? 1, 2, 3. Each carbon atom, the terminal carbon atoms can have 3 hydrogen atoms, and the carbon atom in the middle can have 2 hydrogen atoms. So how many more hydrogen atoms can be added to this molecule? Here you can add 1 and 1, 2. Here you can add 1 and 1, 2. So 4. So 4 more hydrogen atoms can be added to this compound. As a result, this is unsaturated, and you can say this is unstable also. So IUPAC name. How do we give IUPAC name? Prefix plus word root plus primary suffix plus secondary suffix. Here word root. This has 3 carbon atoms. So word root for 3 carbon atoms is prop, and there is no prefix at all. So what will be the primary suffix if it is triple bond? If it is triple bond, then the primary suffix will be YNE. So the name is prop, YNE, propyne, and common name is methyl acetylene. So this becomes the functional group. This group is called acetylene group. This group is called acetylene group. So if you do like this, then what is left? If you separate from here acetylene, if you separate this acetylene group, then what is left? This methyl group is left. So you can say this is methyl acetylene. What is this? Methyl acetylene is the common name. And since here is double bond with carbon only and there is no alkyl group, hence it is acetylene only. But if you see here, after this acetylene group, what is left? C2H5. What is there? C2H5. So alkyl group C2H5 is called ethyl. C2H5 is ethyl, and this is acetylene, so it becomes ethyl acetylene. So ethyl acetylene. For this also, here this is acetylene group. What is this? Acetylene group. And how many methyl groups are there? 2 methyl groups are there. So dimethyl acetylene. This will be dimethyl acetylene. Okay, so these are isomers because molecular formula is same, C4H6, and here also C4H6, and they are differing because of the position of this triple bond. Here the triple bond is between first carbon atom and the second carbon atom, but here the triple bond is between the second and the third carbon atom, hence it is different compound. They are different compounds. So the name, IUPAC name for this will be count the carbon atoms, 1, 2, 3, 4. So if there are 4 carbon atoms, we say but, and since there is triple bond, so you can say but-wyne, and you have to show the position of triple bond. So triple bond is in between carbon number 1 and carbon number 2. Out of carbon number 1 and carbon number 2, which is the lowest number? 1. So it goes with but-1-wyne. Here triple bond is between carbon number 2 and carbon number 3. If you go like this, 1, 2, 3, 4. So they are 2 and 3. And here also 1, 2, 3, 4. So 2 and 3. So between 2 and 3 there is triple bond. So It will be butene. Butene. Then let's talk about the very much common alkyne, and you can say this is the first member of the homologous series alkyne, and the name is ethine. What is the name for this? Ethine. And what is the molecular formula for ethine? C2H2. What is the common name? Acetylene, because C triple bond C is called acetylene group, So ethine is the first member of the alkyne series. Ethine being an unsaturated hydrocarbon. I said why it is unsaturated hydrocarbon? Yes, it is unsaturated because more hydrogen atom can be added. Is not found in free state. So why it is not found in free state? Because it is unsaturated hydrocarbon, and all unsaturated hydrocarbons are highly reactive. Saturated hydrocarbons are less reactive, but unsaturated hydrocarbons are highly reactive. Hence, they are not found in free state. Sources: how to get ethine then. Traces of ethine are present in coal gas. So from where can we get ethine? Small amount of ethine can be found in coal gas and in gases obtained by the decomposition of certain complex organic compounds. It is obtained by cracking of alkanes. The same way we can get ethene. Ethene is also obtained by cracking alkanes from various fractions of petroleum. So same, the source for ethine and ethene is same. By cracking of alkanes we can get ethene as well as ethine. Then structure of ethine. Each carbon atom in ethine is attached to one hydrogen atom by a single covalent bond and to another carbon atom by a triple covalent bond. So in case of ethine, you can see here, carbon has 4 valence electrons. If you consider this dot as the valence electron of carbon, then 1, 2, 3, 4. These 4 electrons are the valence electrons of carbon, and for this 1, 2, 3, 4. These 4 electrons are the valence electrons of another carbon atom. Now these 2 carbon atoms are sharing these three electrons each. As a result, they are sharing 3 pair of electrons. 3 pair of electrons forming triple bond. So there will be 2 electrons in one bond, 2 electrons in one bond, 2 electrons in one bond, and 2 electrons in one bond. Okay, so they are forming triple bond, and with this they have 6 in the outermost shell, with this 7, 8. So for this carbon there are 8 electrons attaining its octet, and for this carbon also this is shared pair, so shared pair is for both the atoms, so 8 for this carbon as well. That means this carbon has also completed its octet, and this hydrogen has completed its duplet by these 2, and this hydrogen also has completed duplet by these 2. As a result, complete stable compound is formed, which is called ethine. So this is electron dot formula for ethine, and this is structural formula of ethine. C triple bond C and a single covalent bond between carbon and hydrogen. So there are 2 hydrogen atoms with a single covalent bond with the carbon atoms and triple bond between 2 carbon atoms. So this is structural formula for ethine. The shape of ethine molecule is linear. So what is the shape of ethine molecule? It is linear. Then lab preparation of ethine. So how do we prepare ethine in laboratory? What are the reactants we use? Reactants we use are water and calcium carbide. What is the molecular formula for water? H2O. And what is the molecular formula for calcium carbide? Ca. For calcium carbide, C2. CaC2. Calcium carbide molecular formula is CaC2. Now let's see what is the procedure for making this ethine in lab. arrange the apparatus as shown in figure 12.5. You can see the figure out here, how the apparatus are arranged. You see it clearly. Take a few pieces of calcium carbide in a conical flask. You can see here this conical flask. This is the conical flask. In this conical flask, you can take calcium carbide. These particles you can see, these are calcium carbide. Okay, calcium carbide. So you add a few pieces of calcium carbide in a conical flask. Add a few drops of water through the Thiel funnel. This funnel is named Thiel funnel. This is Thiel funnel. With the help of this Thiel funnels must be immersed inside water so that the gas do not leak out of this Thiel funnel. So why Thiel funnel is dipped inside water? So that the gas so formed may not come out of this Thiel funnel, or may not escape out of this Thiel funnel, because of which this Thiel funnel is immersed inside water. So add a few drops of water through Thiel funnel. Calcium carbide reacts with water to produce colorless gas with sweet smelling ether-like odor ethane gas. The reaction is exothermic. So when you put water in this calcium carbide, it start reacting. The reaction takes place. So there will be reaction. There will be reaction between calcium carbide and water. As a result, sweet smelling gas will be formed, which is ethane gas. So this gas, whatever is formed, the gas that is formed will come from this delivery tube, and it will go to it will go through this water trough, and it is collected here in the inverted tube. This is inverted gas jar. So this will be collected here by the downward displacement of water. When this gas bubbles goes up, okay, since gas is also matter, so it occupies space. So when it occupies space, the water level goes down. That means water will be moving downward, water will be displacing downward. So this is downward displacement of water. So ethane gas, all the gas whatever we have prepared so far, methane, ethane, ethene, ethine, all are collected by downward displacement of water. So all these gases are collected by downward displacement of water. So how it is prepared? First, again, let me tell you again. First of all, take a conical flask. In this conical flask, put a few pieces of calcium carbide, and with the help of Thiel funnel, add few drops of water. When water comes in contact with calcium carbide, the reaction takes place. As a result, sweet smelling gas will be formed, and this gas can be collected through delivery tube, which is connected through water. Okay, it means through the trough water. In the trough water there is a inverted gas jar, and the upper portion of the inverted gas jar will be occupied by ethane gas by the downward displacement of water. You can see the reaction here. The reaction can be shown like this. Reaction: calcium carbide CaC2 plus water reacts to give calcium hydroxide. What is this? CaOH whole twice, calcium hydroxide, plus acetylene C2H2. So this is ethane that we are preparing. This is the ethane that we are preparing. So in this way ethane gas is prepared. In this way, what is prepared? Ethane gas is prepared. So this is the reaction. This is the arrangement, diagrammatic representation. Okay, and this is the procedure that we follow for making acetylene in lab. Now let's see how do we collect, how do we purify and all. So collection, the gas is collected by this is not B, the, okay, the gas is collected by the downward displacement of water. Why? Because it is insoluble in water. If it is soluble in water, then you will not get ethane gas, because it will be soluble, it will get dissolved in water. Since it is insoluble in water, so that's why it is It is collected by the downward displacement of water. Okay, so they may ask you why ethane gas is collected by downward displacement of water. What must be your answer? Your answer must be the ethane gas is collected by the downward displacement of water because it is insoluble in water. And purification. How do we purify ethane gas? Impurities like phosphine gas, hydrogen sulfide gas, ammonia, and arsine are formed along with ethane. So, due to the contamination of calcium sulfide and calcium phosphide in calcium carbide, whatever reactant you are taking as calcium carbide, that calcium carbide is not 100% pure. The calcium carbide that you are taking as the reactant is not 100% pure. So it is mixed with this one calcium phosphide and calcium sulfide. So that means the calcium carbide that you have taken as one of the reactant contains calcium sulfide and calcium phosphide as impurities. As a result, on passing through water, all impurities except phosphine are absorbed. All impurities except phosphine are absorbed. Okay, so phosphine is absorbed by passing through acidified copper sulfate or acidified potassium dichromate solution. So on passing through water, what happens? All impurities except phosphine are absorbed. All impurities, okay, except phosphine are absorbed. That means these gases like arsine, hydrogen sulfide, and ammonia do not disturb at all because they will be because except phosphine, the rest of these are absorbed. Okay, then phosphine again is there in the ethane gas. So how to purify ethane gas from phosphine, which is not absorbed? So phosphine is absorbed by passing through acidified copper sulfate or acidified potassium dichromate solution. As a result, we will be getting pure ethane gas. So why purification of ethane gas is needed? Because the calcium carbide that we are taking as the major reactant also contains calcium sulfide and calcium phosphide, because of which phosphine, hydrogen sulfide, ammonia, and arsine gas are also produced. But except phosphine, rest of the gases are absorbed when we are passing water through it. And this phosphine can be absorbed by passing the gas, so prepared through acidified copper sulfate or acidified potassium dichromate solution. Now see here, this is the precaution that we need to take. Flask should not contain air as ethane forms explosive mixture with air. So the flask where we are collecting ethane gas should not contain air. Okay, it has to be absorbed by using vacuum pump. Otherwise, when ethane comes in contact with air, it forms explosive mixture and it may burst. The air of the flask is displaced with oil or some inert gas. So air of the flask is displaced with oil or some inert gas. Otherwise, there will be explosion. This is the way how ethane gas is collected and purified. Now there are other ways also by which we can prepare ethane or acetylene. So preparation from 1,2-dibromoethane. 1,2-dibromoethane. What is the common name for 1,2-dibromoethane? Ethylene dibromide. Ethylene dibromide. You can see the structure here. CS2Br, CS2Br. So there are two bromine atoms. So two bromo. That means dibromo. And they are in carbon number 1 and carbon number 2. So 1, 2 dibromo, and there are two carbon atoms, so eth, and since there is single bond between carbon, so N. So 1,2-dibromoethane. And what is the common name for this? The common name for this is this CH2 and CH2 group makes ethylene, and this is bromide. Since there are two bromines, so it becomes 2-dibromide. So the common name for 1,2-dibromoethane is ethylene dibromide. So when 1,2-dibromoethane or ethylene dibromide is boiled with alcoholic potassium hydroxide, Ethane is formed. This is very much easiest way, a simple way of preparing ethane gas. Okay, simple way. Simply you mix this 1,2-dibromo ethane with alcoholic potassium hydroxide solution and boil at the temperature of 200 degrees Celsius. Then you will be getting gas, ethane gas, along with potassium bromide and water. Along with potassium bromide and water, what is formed? Ethane gas is formed. So what is your product? Product is ethane gas. These are the byproducts which is formed along with ethane. So two ways of preparing ethane is discussed. One is using calcium carbide and water, that is lab preparation for ethane, and this is one other way of preparing ethane by passing 1,2-dibromoethane through alcoholic potassium hydroxide and boiling it at 200 degrees Celsius. Then like alkenes, all unsaturated hydrocarbons undergoes addition reactions. Okay, unsaturated hydrocarbons undergoes addition reactions because more hydrogen atom can be added to them. Only saturated hydrocarbons undergo substitution reaction. So similarly, like that of alkynes also undergoes addition reactions. Alkynes are unsaturated compounds, so they are associated with addition reactions since triple bonds break up easily. So triple bonds break up easily. The breaking up of a triple bond gives a product that is still unsaturated, that is double bond. Further breaking up of the double bond gives a saturated product. So first of all, in alkynes what happens is when this triple bond breaks, then the product formed will have double bond, that is also unsaturated, and this double bond further undergoes breaking. Okay, it further breaks up to give saturated product, that is alkane. So alkyne, first of all, alkyne gives alkene and alkene gives alkane. So let's see. Addition of hydrogen, addition of hydrogen, addition of hydrogen. Yes. So catalytic hydrogenation, addition of hydrogen is also called catalytic hydrogenation. Okay, catalytic hydrogenation. So this is catalytic hydrogenation. In the presence of nickel, platinum or palladium, these are the catalysts. Okay, nickel, platinum or palladium are the catalyst. Ethane first takes up 2 atoms of hydrogen to change to ethene, which further takes up 2 atoms of hydrogen to give ethane. So let's see stage wise. First stage of reaction. So you can see here the first stage of reaction. So in addition of hydrogen means in each and every step hydrogen will be adding. Catalytic hydrogenation. Hydrogenation means addition of hydrogen. Catalytic hydrogenation means addition of hydrogen in presence of catalyst. Okay, addition of hydrogen in presence of catalyst is called catalytic hydrogenation. So what are the catalysts we use in addition of hydrogen? Nickel, platinum or palladium, any can be used. So first of all, ethane, this ethane, C2H2 ethane, in presence of hydrogen. Okay, this ethane breaks. First of all, this ethane breaks. You can see here, this is ethane, triple bond is there, ethane breaks in presence of nickel. Okay, and when it breaks, then one hydrogen atom comes and added here, one hydrogen is added here. As a result, it gives CH2 and here also CH2, which forms ethene. Again, this ethene in presence of nickel. Okay, this bond breaks. So on breaking of this bond, one hydrogen will be added to this carbon and one hydrogen will be added to this carbon. As a result, this carbon will have 3 hydrogen atoms and this carbon also will have 3 hydrogen atoms. As a result, it forms ethane. So let's see this step. First stage, ethane in presence of nickel breaks and 2 atoms of hydrogen will be added to each of the carbon atoms, so it forms C2H4. Then again this C2H4 in presence of nickel breaks, okay, and two more hydrogen atoms can be added. As a result, it gives ethane. It gives ethane. So ethine, so in this way, addition of hydrogen can take place in ethine. So ethine, first of all, with the addition of two hydrogen atoms, it becomes ethene, and ethene with the addition of two hydrogen atoms, it becomes ethane in presence of nickel. So this is addition of hydrogen. And then addition of halogen, reaction with chlorine. Ethine is an, this is not in, this is, ethine is an inert solvent like carbon tetrachloride. For example, adds chlorine to change into an ethene derivative with carbon-carbon double bond, and then to an ethane derivative with carbon-carbon single bond. Let's see the reaction here. This is ethine. So ethine, when reacts with chlorine from carbon tetrachloride, then what happens is this triple bond, this bond will break. One bond will break, and this bond breaks. In addition of hydrogen, we were adding hydrogen atom. In addition of halogen, we'll be adding halogens. We'll be adding halogen. So with the breaking of this bond, one chlorine will be added to this carbon and one chlorine will be added to this carbon. As a result, it forms CHCl, double bond CHCl. So what is the name for this? 1,2-dichloroethene. 1,2-dichloroethene. Again there is a double bond, so this double bond again can break, okay. So when this double bond breaks, again one chlorine atom can be added here and one chlorine atom can be added here from this chlorine which is coming from carbon tetrachloride. So there will be single bond, and it will be having, this carbon will be having two chlorine atoms, and this carbon also will be having two chlorine atoms. So it forms 1,1,2,2 tetrachloroethane. This forms 1,1. Why 1,1? Yeah. Why 1,1? Because two chlorine atoms. Okay, two chlorine atoms are added here, and the position of these two chlorine atom is 1,1, and the position of this two chlorine atom is 2,2. So 1,1,2,2 tetrachloroethane will be formed. Acetylene reacts vigorously with chlorine gas in the presence of sunlight to give out flames. So when acetylene reacts vigorously, when acetylene reacts with chlorine, it forms carbon along with hydrogen chloride, in presence of sunlight. In presence of sunlight, this ethine can react vigorously. So we have to do this reaction in absence of sunlight. In absence of sunlight, we can do this reaction to get tetrachloroethane or 1,2-dichloroethene. So this is addition of halogen, a reaction with chlorine, and reaction with bromine is also same. When bromine in carbon tetrachloride is added to ethine, its brown color disappears due to the formation of addition products. The reaction is similar to the addition of chlorine. So the same way we did with chlorine. C2H2 ethine, then this Br2, two atoms of bromine. Bromine molecule is added here. When the bond breaks, this bromine is coming from carbon tetrabromide. So this product is from C2H2 Br2, which is also called 1,2-dibromoethene. Then this ethene again can undergo addition reaction, and then we get C2H2 Br4. As a result, this will have single bond, and the name is tetrabromoethane. For this, we can go back like this only. This way only. The mechanism is similar to this, okay, similar to this. So this can be done in class in a very nice way, okay. Then if you for reaction with iodine also is same way the reaction takes place. So iodine reacts slowly with ethine in presence of alcohol to form a diiodo derivative. So the reaction with iodine is really very slow. The reaction takes place in presence of alcohol. Okay, so CH triple bond CH reacts with iodine in presence of alcohol to give. Here is iodine attached to this carbon atom. Here is iodine attached to this carbon atom. As a result, it forms diiodo. Why diiodo? Because there are two iodine atoms in the molecule. So, diiodo derivative is formed. Then the uses of ethane. Uses of ethane. It is used for oxyacetylene welding at very high temperatures. These temperatures are obtained when ethane bonds in oxygen. So for oxyacetylene welding at a very high temperature, ethane is used. It is also used as an illuminant in oxyacetylene lamp. Illuminant means which gives out the light, For artificial ripening and preservation of fruits also ethane is used. So more or less the use of ethene is similar to that of ethane. Also for the manufacture of synthetic products like polymers, artificial rubber and oxalic acid, this ethane is used. For the manufacture of important organic compounds like acetaldehyde, acetic acid, plastic and rubber also ethane is used. This much for today, and with this we have finished Organic Chemistry chapter 12, okay, as per your reduced syllabus. So this much for today. Thank you.